Hello everyone, my name is Ehsan Hassankiadeh. I'm doing my Master's Civil of Engineering in UOW, and here I am for present designing of connection for beneficial deconstruction. Today, first of all, I would mention that deconstruction definition is really important. Beneficial deconstruction means that disassembling of a structure that is separated parts can be reused in other buildings. It can be reused in components to the other buildings, directly reused in other components. It has involved 4 sections. First of all, designing. It should be designed fundamentally and the basic level of a building for design. Next step is the cost of the construction. We have to estimate, and we must estimate the cost of our construction, because it is really important that we have to know that how much money we have to spend in the construction. Reusing and recycling. Reusing and recycling have 2 different meanings. Reusing is that the direct reuse after life cycle of one component. Recycling need to remanufacturing of components. You go to the remanufacturing component and after that come back and reuse. Next is the environment. Environmental hazard of waste and demolition waste, and there are a lots of landfills. Next slide that I want to mention to you is 2 different life cycle of buildings. First step that need to build a building is that excavation of natural resources. We need the resources for our buildings, for our materials, processing into materials. After that, manufacturing into components. After we find the resources and materials, we can build good components and appropriate components for our building. After that, assembly into building. Okay, we carry out the components and assembly them together. After that, our building are complete now, and we can use them. After the life cycle of building, we have one more step. This is assembly of building. We can do demolition of building. After that, it's waste for dumping. This step is without any design for the construction in basic design. But if we done this, we can have a good cycle. First step, after disassembly, we can recycling our materials to processing into materials. After that, reprocessing of materials to manufacturing into the components, to the process of a building, good components for all building. After that, reusing of components. Okay, after that, we can assembly into building of components, and after that we can relocation of whole building. You can go to another location with the same component as we used before in another building. Next slide, I want to present and illustrate layers of a building. First layer is a site, is not movable. As it's mentioned here, it's not movable. Site like foundation, like piling system in the ground. Layer 1 is a structure, elements like beam, columns made of steel or maybe concrete, is no matter. Layer 2 is skin, exterior walls, cabling like panels and roofs. Layer 3 services, plumbing, electronical, mechanical services, or something like that. And layer 4 is a space plan, internal walls, partitioning and finishing and furniture. Layer 5 is stuff, item movable around the building. Next slide is about concrete and steel assembly. And for steel assembly, we need to crushers and pulverizers for reinforcing steel bar from concrete structure, and heavy duty magnets we need for separate steel from concrete. And it is really useful method for this, for steel assembly. Next slide is about concrete. We have two different methods for the assembly of concrete. One thing is high pressure watt jetting, and heating. And we have two different types of concrete also. Casting place, that is really strong and it's not movable and cannot be reused in original form. As you can see in this picture, it is really strong, and this part is a foundation of a structure. It's layer 0 that I told you in the before slide. This way, the precast concrete is easy to disassembly and reusable. They can, before they come in, and carry them into the main site and assemble them together. Next slide is the construction detailing. First, access. Access has three different types. A sequential access, it depends to the layer of building. It really depends to the layer of building where do you want to do access to them. Physical access, ability to reach elements and components for remove or repair itself completely, and access to fixing is need to special tools to access. We have also three different type of connection. One, direct connectors is usually overlaps with components. It overlaps together, and it can make tough and difficult assembly process for us. Indirect connectors, it depends from components, and they usually make easy reconstruction process because they're independent from together. Infill concreters is impossible to reconstruct, and I told you like the casting place concrete or something like infill. It's like infill concreters. Okay, next slide is about type of connection between elements, between components. Square fixing and nail fixing have advantage and disadvantage, and I present them for comparison of all our connections, because it's really important to choose best connection for all building, because we need to reconstruction, we need to beneficial reconstructions. Square fixing is easy removable, and nail fixing is speed of connection. It's improve our speed and cost. Disadvantage of the screen is limited reuse of both hole and screen and nail fixing. Disadvantage are difficult to remove, and remove usually destroyed case area of elements. Friction keeps construction elements whole during removal. It's the advantage of this connection. And relatively undeliverable area and poor choose fixing structure. And mortar also can be made variety of structure, but it's not reusable. I think it's disadvantage, it cannot be reused and difficult to separate. And last, resin bonding. Resin bonding is really interesting for me because it's strong and efficient and deal with acquired joints. For example, some empty area, some empty space, you can feel all the empty space, and it is very good and useful. But it's impossible. It's impossible to separate bonded layer, and it is really difficult to reuse and recycle. Cost. Cost is one of the most important elements and factors in the construction. We have to estimate the construction of this. Ratio between, I want to present economic in the construction sustainability indicator, DSI. And this is ratio between economic saving, which is about replacing conventional demolition and landfilling with the construction, and the total cost of the conventional construction. That's in the formula. I is a number associated with the appropriate component, and here and here. Total number of building or components. Next is CC. This is here is the cost incurred in production, transporting, installation, and particular building components. ACC, additional costs required to originally component to the involved with the relevant properties appropriate. PRP, price of the recycling component, it was the pursuit from the natural raw materials. and CT is the transporting cost during the construction. I think that this is one of the limitations of this formula, because we have a lot of transporting side in the CC. But anyway, another part is CD, cost incurred for demolition and disassembly, and I think it's a CR, cost of the recycling process, and CDL, saving in the construction cost. With this, we can estimate all the prices for RD construction, and I think that present all the elements that need to know about the construction materials. Okay, thank you for your time. If you have any question, here is my email address. I can illustrate more things to you. Thank you.